And okay, guys, we're gonna start in a few minutes. Okay, live stream. Yeah. Actually, everybody can hear you, so please be quiet. I started the live stream and I'm about to unmute. Okay, guys, so let's get started. Today we're going to be learning about trigonometry. Let me just edit this because I forgot to change it first of all. I need to trigonometry. Okay. Okay, so that's trigonometry, and so let's get back don't think this is gonna load. Okay, yeah, we just have to reload the page. Okay, boom, it should load now, maybe. Yeah, there we go. Okay, so we're gonna go on to Unit 8, trigonomic functions, trigonometric functions, okay? So let's go on to 8.1 first of all. Values of trigonometric functions. So basically, like, you have trigonometric functions, which are like, everybody knows like sine, cos, and tan, right? Like sine, cosine. Let me get my annotation tool. Okay, so does everybody know something called SOHCAHTOA? TOA? I messed up the recording, I'm pretty sure. Oh no, this is bad. So yeah, it breaks over, guys. So yeah, let's get started. And there we go. So we have to connect this to the TV or the computer on Xbox, and then you can just. Okay, sorry about that, guys. Okay, sorry about that, guys. I was doing something. I had to be. I was gonna be right back. Okay, so find all the missing sides and angles for the right triangle when BC is equal to 8 and AB is equal to 20. So round your answers to the nearest tenth. So let's look at what this is saying. Okay, let me get my drawing tools. Basically, you have a triangle when BC is equal to. So let's first draw this triangle. And you have this, this, and this. So this is BC, and this is 8. AB is 20. This is 20, and this is a 90-degree angle. This is a 20, and we're trying to find B. I'm pretty sure. No, we're trying to find all the stuff that it didn't say. So we're trying to find this, this, and B. So yeah, so that, do you want to do this one?
Oh, can I do this one?
Yeah.
Okay, so for this one, you can use the Pythagorean theorem because you know the length of two sides.
You're glitching out.
I'm glitching.
Yeah.
Can you hear me better now?
Yeah. I can hear
Okay.
you better now.
So now we can use the Pythagorean theorem because you know the length of two sides. So okay, 9. Okay. So
Yeah, you use the
6.
Pythagorean theorem.
Okay. And then I got okay, and then I got 336, and then now I have to square root that.
Yeah.
Okay, that gives you a big decimal. It gives you 18.330 or something. I'm just gonna round to 18. It says round your answer to the nearest tenth, and this one is 18.0 something. So I'm just gonna put 18.
Okay. So it's 18.03 or something?
Okay. Oh wait, sorry, 18 point. No, it was 18.3.
Okay, yeah, that's what I thought. Yeah, let's keep
Okay,
going. Angle A.
and then okay, so now we know all the length of all of these sides. So now we can calculate them. So A. Hmm. So you can either use uh hmm.
You can use the sign. It doesn't really matter. You can use whatever you want since we have all the sides. Just choose a random one.
Okay. I'm gonna do a cosine of
Why cosine?
angle.
Wait. Why cosine? See, this has a decimal. These two don't. So I'm pretty sure a sine would be easier because it's just 8
Okay.
divided by 20, which is 2 over 5. So that's 0.4.
Wait. Okay, yeah. That gives you 0.4
Wait, no.
and
That that
B
that gives you that gives you a 0.4 as the
0
sign.
0.4.
Yeah, it gives you 0.4 as a sign, but then you have to like sine to the power of -1 that. So you have to do 0.4, and then you have to take the sine to the power of -1, and that gives you 23.5 degrees. Sorry, 23.6 degrees. And so yeah, that's what you got. 23.6 degrees. And that's because
Okay, and
remember
now,
that only gave you the sine because you're doing 2/5. That's
oh
the sine
yeah,
of A. And to
okay,
like get the actual angle of A, you have to do sine to the power of 1. So yeah.
okay. So to find B, we could use cosine, I guess.
Yeah.
So cosine, so BC, that's 8, and AB is 20, same thing.
Yeah.
And that gives
Divided by 2.
you 4. Oh, no, it's 8 over 20, sorry. 8. That gives you the same thing, 0.4.
Yeah.
And since I'm using cosine, 0.4. Okay, that gives you 66.4.
66.4. Okay, yeah, that seems
Yeah.
right. 66 point. Okay. 66.4. There we go. Okay, so do you want to also do this one?
Yeah, sure. Okay. Find all the missing sides and angles for the right triangle when angle B is 36 degrees and BC is 20. Could you just mark those, like the angle B and BC? Could you mark those?
Yeah. I was just about to. This is 36, and then BC is 20, and that's all they give you.
Okay. And round your answers to the nearest hundredth. Okay. So we gotta find everything. So angle B. We don't have enough information to find the angle B. I
Yeah.
mean, not angle B. We don't have enough information to find a B. So I'm just gonna let that wait for a while.
We
Okay. So
definitely have
we know.
we already have enough information to find any of these. We can find any of these using just this. So, let me give you an example. You can definitely find B using just these two. So basically, what you can do, I'm just gonna do sine. I'm just gonna do number B. This one. You can do the rest, but you can just do a lot with these two. So basically, this is the opposite. So basically, you're gonna use sine. So sine of 36, sine of 36 is equal to 20. Sorry, it's equal to b divided by. Actually, no, you're gonna use tan. Okay, I was wrong. You're gonna use tan because you don't have the hypotenuse. So that's tan of 36. Tan tan of 36 is equal to um what is it? It's b over 20. And yeah, this is 20. It's 36. And so basically you can do tan of 36 times,
Okay. I forgot the side of B.
yeah,
That the side of B is 37.32. I mean, no,
37.32.
333. 37.33.
3. Okay, so let's see if that's right. So um, basically 36, and then you take the tan of that, and then you do multiplied by 20. Yeah, it gives me 14.53, not 37.33. I think where you got confused was
It's a tan of 36 times 20. Okay, yeah, I did
yeah,
that wrong.
yeah. What did you do?
Oh, actually, I did the tan of 36, but then after I did that, I took that and I did 10 over -1, and I did all that.
Okay. Okay. Yeah, I see. Yeah. So yeah, you can do the rest
Yeah,
of this.
that gives me 14.53. Yeah. So angle B is, I mean, side B is 14.53.
Yeah. So can you
Okay.
find side
So
C?
no, the side of B. So we can just do that. And okay. So it's 20 squared. So it's 400. Uh, plus uh, what's 14.53 squared? That gives you approximately 211.
211.
So
Okay.
I'm just gonna use 211. Yeah, it gives you approximately 211.
Okay.
So I'm just gonna do that, and then you get 611 and square root that, and that gives you 24 point 71. I mean 72. 24.72.
Okay. Okay. 24.72. Oops.
Okay, now we have to find. Now you have to find degree A. So for this, we can basically use uh, cosine
You
adjacent
don't even
over
have to
that.
use any of that. You just do 90 minus 36 because all the angles of a triangle have to add up to 180. You know that, right?
Oh yeah,
Yeah, you can just, since this is already 90 and then this is, and then 180 minus 90 is 90.
that gives you 54.
Yeah. Good job. So Satvik, do you want to do number 3? I think I already did this at some point. No, we didn't. Okay. So Satvik, do you want to do number 3?
Um, I don't know. I don't know how to do it.
So if you were listening to Sid and I, if you're listening to Sid and I doing the problems, then I think you should have understood. But whatever, I'm just gonna explain it again. So
But could you mark them first?
yeah, that's what I was about to do. So basically, you have BC is 39. It says it right here, and angle A is 26, and that's all they give you. So using this, they asked you to figure out side B in the figure. So side B is this, and they want you to figure this out. So you have to use trigonometric ratios, which is what we learned last in the last lesson. And so yeah, you have to use that to like solve this. So Satvik, can you do that?
Yeah.
Oh, yes, I like this one. I don't know why I like this one. No, why did I like this one so much?
It had games. Actually, that's because it had games. Remember?
Oh, yeah. Why do I like games so much?
The answer is 78.3.
Okay. Let's see if that's right. So obviously we're gonna use tan for this because tan is the perfect candidate because you're trying to find B and they give you the opposite, and this is the adjacent. So you do opposite over adjacent. Opposite over adjacent, and basically you do 39 over adjacent, so you do B is equal to opposite, which is 39, divided by 26 tan. Okay, I ran out of space. I'm gonna write that again. So you do B is equal to 39. And
It's 39. Uh, it's 39 by 10 of 26 equal 39 by B.
okay. Okay, so yeah, good job, Southwick. But let's actually calculate that. So you have 39. Okay, oops. 39 divided by 26 tan, and you get that, and you get 79.9, which is 80. So I think it's actually 80. So you get 79 point. Let me try that again. So you have 39 divided by 26 tan. Yeah, you get 79.96. That's 80. Okay, I think Satvik, you're wrong. For some reason or another. So
Okay.
I think those are the types of problems that you get in this thing. So we're just gonna leave this one as it is, and we're gonna do some other stuff. Okay, so application problem. Okay, law of sines. So this stuff is pretty cool, but it's complicated. Okay, so we're gonna get into some complicated stuff. So I'm going to slow down a lot. So the law of sines. I'm just gonna say the formula before they do. So basically, the law of sines is just this is the law of sines. Okay, so the law of sines is sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C. This is the formula. So yeah,
Looks like a pretty easy formula.
yeah, it's super easy to remember, and yeah, it's pretty easy to use also. So this is the law of sines. For any triangle ABC where A, B, and C are the lengths of the sides opposite angles ABC. So what this is saying right here is it's saying that ABC, like the angles ABC, are like at the opposite of the sides ABC. So let's say this is a right triangle, but this never says that it has the. So the law of sines applies to any triangle, not just a right triangle. So it even applies to like this, like weird looking triangle right here. This looks like a right triangle. So it even applies to this weird looking triangle right here. So yeah, it doesn't just apply to right triangles. It applies to all triangles. So basically, you have law of sines, and so they want A, the angle capital A, to be over here. It doesn't necessarily have to be over here. It just has to be opposite of the lowercase a side, and it wants B to be over here, C to be over here, C to be over here, and B to be over here. It wants like the capital letters corresponding to the lowercase letters on the opposite side. That's basically what it wants. And yeah, that's the formula. So it's like super easy to remember and super easy to use. So let's find out how we can actually use this, and in what cases do we actually do use this. So basically, I'm trying to find it. I don't. know where I found it before. Okay, ASA or ASA. Just 1 second, guys. I forgot where to find the thing. I don't remember. Okay, here. This is where it is. So, you use it when the measure of two angles and the length of the side are known. Or you use it when the length of the two sides and the measure of an angle opposite one of the sides is known. So basically, this is what it's trying to say. Let's just draw a sample triangle right here. Let's draw an equilateral triangle. And this is A, this is B, this is C. C, A, B. So everybody got it up till this point, right?
Yeah.
Okay, so basically after this, it gets a little bit weird. So Satvik, did you get this? You have a triangle with A, B, and C as the sides, and A, B, C as the angles.
Yes.
Okay, so with this, so let's say that they gave you the measure of angle A, and they also gave you this side is equal to 6, and this side is also equal to 6. And this side right here is equal to 60. Let's say they gave you this thing. So basically with this, you already know that it's an equilateral triangle, and you know that all of these sides equal 6 and all of the angles equal 60. But let's just try it using this formula, using this property or whatever, or law, whatever you want to call it. So it says C is equal to 6, A is equal to 6, and you have A is equal to 60 degrees. I forgot the degree sign. So now we have the measure of two sides. We have the lengths of two sides. See, we have this side and this side, and we have the measure of an angle opposite one of the sides. See, this angle is opposite A. So we have it. So yeah, that's pretty cool. So that means we use this formula instead of another formula that I'm going to talk about tomorrow, because I don't think we have time to. I mean, we might, but probably not. I don't know. So
Okay, so I solved that. And I got 0.144337567. A big little thing.
for which? For what?
For that problem you just drew.
What did you solve for?
The sign, like the formula. I used the formula to solve that problem you drew, and I got. So I did this as A, like angle A,
Yeah.
and then I divided that by 6,
Okay.
and then I got 0.
So you did. Sorry, I cut you off. But so you're saying that you did. 1 second. So you're saying that you did sine of angle A divided by A. This is what you did?
Yeah.
Okay. So that's not exactly what this is used for. It's for solving like sides, like we used with the normal trigonometric functions. Ratios. But but instead of only right triangles, this is used for any triangle, ever. So yeah, that's why this is significant and cool. Or at least that's why I find it fun and cool. So basically you have sine of angle A, and you have A. So let's say you want to get the length of B. So you don't have the length of B. So let's get away from that. Let's say that you want to find the measure of angle C first of all. So basically you have to find the measure of angle C. So let's see. Sine of C over C is equal to 6. So you put that on the bottom. And you have A, which is also equal to 6. And now you bring this to this side to solve for sine of C. So you'll get sine of C is equal to sine of 60 sine of 60 divided by 6 times 6. So you just get sine of 60. So if you get sine of 60, then you get the sine of C. And we already know that C is 60 at this point because the sine of an arc of 60 is 60. So we have 60, and we take the sine of that. Okay, take the sine of that, and then you take the inverse sine of that, and you get 60. Voila, we have C. Okay, we have C is equal to 60. What a coincidence! This is an equilateral triangle. Yay! And this is obviously equal to 6 because this is an equilateral triangle. All of the sides are the same and all of the angles are the same. So yeah, Satvik and Siddharth, did you kind of understand that? If you have any questions, ask them now.
Okay. But the part I don't understand is you put sine of C equals sine over 60 over 6. Why would you do that? Like, you put sine of 60? Why?
Okay, so sine of 60. Okay, so why did I put that? So over here it says sine of A, right? You see that?
Yeah.
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 So we have the measure of angles. We have the measure of angle A, right?
Yeah.
And that's 60. So you just replace A with 60 because we know the measure of angle A. So we just put 60 over there.
Oh, yeah.
Yeah.
Okay, yeah, that makes sense.
Yeah. That's also the reason why we know the measure of angle C. Okay, so yeah, good questions. Satvik, did you understand? If you have any questions, this is the time to
Yes,
ask.
I did.
Okay, good. Okay, so let's clear the screen and let's do some practice. So it says find missing side B in the triangle shown below. And so let me just draw the measurements on there. There it says. So it says A, measure of angle A, is equal to 116 degrees, and measure of angle C is equal to 31 degrees, and A is equal to 24 millimeters. I'm just gonna write 24. So yeah, 24. There we go. And scroll down. Okay, so yeah, multiple choice. So Sid, do you want to do this one?
Yeah, sure. Okay, so find the missing side B. A equals 24 millimeters, and angle A is 116 degrees, and C is 31 degrees. So we can find angle the angle of B really easily. The angle
Wait,
since
wait. It didn't ask you to find the angle,
okay, yeah.
and finding the angle has no use.
Okay. So okay. So we're gonna have to use the formula,
Yeah.
the law of sines. Okay, so we don't know the angle of B or the side of B, so we can just do sine of A as the side A. Okay, sine of A, which is
Wait,
116.
wait, but we can find the angle of B using like the 180 rule.
Oh yeah, 180. Okay, so
180 minus 31 minus
4.
116.
Okay, 180 minus 147. That gives you 33. So 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 sine of B. I mean the side B. Okay, I'm messing myself up. So the formula is sine A over A equals sine B over B. That's
Wait,
basically all we
what
need
was
right
the
now.
angle that you got?
The angle?
Yeah,
Oh, the angle, 33.
33. Okay.
Yeah. Okay, so we know all the angles. We just have to find one of the sides. Okay, so we have to do sine of 33 over B. Just something we really don't know. So I'm just going to do A for now. So sine of 116, that gives you something. And divide that by 24. And that gives you 0.037 something. Okay, 0.0374. And I'm just going to sign negative that. 0.0374. Like 2.14 or something. Okay, so that gives you 2.1433 or something.
Okay.
Oh wait, no,
I think
wait,
that's
wait.
wrong
I'm
though.
doing something. Wait. Oh, yeah, I'm doing something wrong. Yeah.
So I wrote the
Kind
equation
of.
here. Here, look. Just a second. So
Okay.
this is the law of sines, right? Basically,
Yeah.
you have sine of A is equal to the sine of B, and both of them are like over A and B respectively, and so we can just like substitute all of that except for the thing that we want to find out because we don't know that. So now we have to isolate B first of all. So we just solve it like an algebraic equation, and we do sine of 116 over 24 is equal to sine of 33 over b. And so to isolate b, we have to cross multiply, basically. So we do that, and we
Okay, so
get
that gives you 14.5431.
14.54. Okay.
Okay, yeah.
So were you listening to what I said? I was just saying that you have to cross multiply to like kind of simplify this and
Yeah.
isolate b. So did you kind of understand that?
Yeah.
Okay. So yeah, Satvik, do you want to do the next one? Then I think.
Yeah, sure. I can try to do it.
Okay. Okay, Satvik, did you get anything yet?
Yeah, I'm working on it. I'm almost done. Yeah, okay. So the answer is the third one.
Okay. Well, how'd you get that?
I did sin A by 19 equal sin 57 by 17. That's by 17. And then I did sin A equal 0.933. I mean 3733. No, it's 0.93733.
Okay.
And A equals sin minus 1 bracket 0.93733 equals 69.6 and 110.4.
Oh, okay. So what was in here?
Oh, what was in where?
In this place? A is equal to sin of...
No, the minus 1, it's outside the brackets, like in the
Oh,
like
okay, okay, I
power
see.
spot.
Yeah.
And then bracket, and then it's 0.9373.
9373. Okay, yeah, I understand. Yeah, I see what you did. Okay, good job. Yeah, good job, Satvik. So let's do a few more. Actually, I want to leave it here since there's only 2 people. Because I think I'm going to be reteaching all of this material tomorrow because, well, Rohan wasn't here a little bit. So we're going to be doing this practice tomorrow also because Rohan wasn't here. And, yeah. So I think this is the end of class. See you tomorrow. I know it's a little bit early. But yeah, I think we're gonna leave it here.
Okay, bye.
Okay,
Okay, bye.
bye. See you all tomorrow. Okay, done.